I'm going to write about enantiomer. Enantiomer. So what is enantiomer? So non-superimposable mirror image of compound is called basically enantiomer. So write a point. A mixture containing two enantiomer in equal proportion. In equal proportion have zero optical or will have zero optical rotation. Zero optical rotation. Why it is so? You know that these enantiomers will not be superimposable. That means one will be on left, then another will be right. They are opposite to each other. So one of the compound will be L, that means levorotatory, anti-clockwise. Then the second compound will have D, dextrorotatory, which will be clockwise. So when they will be mixed in a equal proportion, one will move to clockwise and another will move to anti-clockwise. That will cancel its effect, and that's why it will have zero optical rotation. Is that clear?
Yes, sir.
Is that clear? See, such mixtures are called basically racemic mixture. When such mixtures are called racemic mixture. When these enantiomers mix in 50:50 ratio, 50 ratio, then racemic mixture form. And racemic mixture is what? The compounds mixture which will have zero optical rotation, and the process is known as racemization. And the process is known as racemization. Okay. Sneha, so we just started from here. So we have mixture of two enantiomer that are non-superimposable. So both the enantiomer, one will have D rotation, then another will have L rotation, anti-clockwise and clockwise. Then they will mix. And if you are going to check the rotation, one will move. That's why opposite in direction, there will be zero optical rotation, and such mixtures are called racemic mixture. And the process is known as racemization. Is that clear, everyone?
Yes, sir.
Okay, thank you. Let me know when all of you done with this. Nafisa, Hamza, and Sneha.
Yes, sir. Finished.
Done?
Yes, sir.
Very good. Sneha, do it and let me know. Very good. Now see, we have another term that is known as retention. What does this retention means? Basically, before the reaction and after the reaction, that means we are talking about reactants and product. So if you will see at reactant, the spatial arrangement of the bonds will have the same spatial arrangement of bonds in product too. There will be no difference in a spatial arrangement of bonds. Like if I'm going to take an example, before that I'm going to write a point about it. This is basically a retention of configuration is the preservation of a spatial arrangement, a spatial arrangement of bonds to an asymmetric center. Asymmetric center during chemical reaction. During chemical reaction. So I'm going to take an example which will help you to understand it in better way. We have a reaction like this, a reactant, sorry. We have a reactant, solid waste, dash waste. So this is CH2, and with this CH2 there is OH, and this is carbon, and this is hydrogen, and this is hydrogen, and this is CH3, and we have then CH2, CH3. To react this with HCl, if it is going to retain itself, you can see this bond will break, and what happens here after reaction? This is CH2 and this is Cl. This is hydrogen. This is CH2 and CH2. This is CH2 along with H2O, you can say. Now you can see in the reactant, Cl is OH is replaced by Cl in the same spatial arrangement. It can also go to other arrangements like inside the plane or outside the plane, but it retain itself. If OH is on the plane, OH is replaced by Cl, and Cl is also going on the plane. So it this reaction does not alter, called retention. Is that clear? Nafisa, Hamza, Sneha?
Yes, sir.
So please write it.
Sir, what is the word after preservation of?
Spatial. Wait a minute.
Okay.
Done, Sneha. Nafisa, are you done with this?
Yes, sir. Finish.
Okay, Hamza. Thank you. Now we have another terms like oh, wait a minute. Inversion, retention, and so these points will also be clear with the help of example. So I'm going to write a reaction. So you can see this is a carbon with which hydrogen is attached. CH3 is also attached, and then here it is C2H5, and then again here it is X. Now you have seen that in two reaction there will be back attack. Always in SN2 you have seen that back attack will be there. From front side the reaction is not possible. If you remember, please let me know, and if you don't remember, please let me know. I will explain again. In SN2 reaction,
Yes.
if you are going to react this SN2, so you can see if you are going to react this in front from front side, this will go like this negative, and if
Yes,
it
sir.
wants to come here, there will be repulsion between these two nucleophiles, negative charge. That's why in reaction there will be back attack, and from back attack OH can easily attack. Yes or no?
Yes, sir.
Is my video lagging, Nafisa? Is my
Yes,
video
sir.
lagging?
Yes, sir. A little bit.
Okay. Now you can see in SN2 only back attack is possible, but in SN1 there will be formation of carbocation, so it is possible to attack from front side as well as back side. Yes or no? So I'm going to react
Yes,
this
sir.
with I'm going to react this with Y. So two possibilities there. X is replaced by Y at the same place as X is there. That means X will go to Y. This is C2H5. Inversion, inversion, that means opposite. So can you tell me this reaction that I just writing is inversion or a retention? Nafisa, what do you think? Is it inversion or retention? This is equal
Retention.
retention because y is x is replaced by y, and y goes to
Yes.
the same spatial arrangement to the same place as x. But when you are going to react this y, it is also possible for y to come on the right side if it will change attacking side, front side or back side. So this is hydrogen and this is C2H5. Now can you tell me what it is? What do you think? Inversion or retention? You can see in retention,
Inversion.
y takes place of x and goes in the same direction or same orientation. But in this, y is on the right hand side and x was in the left hand side.
Yes,
So
sir.
isn't it inversion?
Yes, sir. It's inversion.
And if you are going to react this y, if you are going to mix this A and B in equal proportion, these are enantiomers. If you are going to uh, superimpose these compounds A and B, they will not be superimposable. That's why they are enantiomer. Yes or no?
Yes, sir.
So that's why they are non-superimposable. First write it, then I will write some sentences about this, which will be very important.
Yes, sir. Finished.
Done. Very good. Thank you. Uh, Sneha, are you done with this? Yes, sir. Sneha, are you done with this? Okay. Thank you, everyone. Now see, I'm going to write about A, B. So first of all, we can write A is, oh wait a minute, I'm going to write all the point. If A is the only compound, if A is the only compound obtained, only if A is compound obtained, process is called retention. If B is the only compound obtained, B is the obtained, the process is called version of configuration. You can also write retention of configuration. And the most important point is that if A and B is everyone there,
Yes, sir.
sorry, I just got disconnected. Now you can see if a 50 is to 50 mixture of A and B is obtained, the process is called the process is called racemization. The product is optically inactive. Why they are optically inactive? One will have D rotation and one will have L rotation. Rotation will be zero. That's why they are optically inactive. Is that clear?
Yes, sir.
Let me know when you're done with this.
Yes, sir, finish.
Sneha, Hamza, both of you done with this? No, sir. Okay, take your time. Done. Very good. Now see, always remember that in SN2, since it is back attack, so there will be inversion of configuration. But in SN1, you can see attack can be from front SMization, and SN2 is accompanied by SN2 accompanied by inversion of configuration. So I'm going to write a point. SN2 reactions of optically active halides of optically active halides are accompanied by inversion of configuration. Like if we are going to take an example, there is bromine optically active. That means it should be chiral. This is CH3. Sorry, H. This is CH3, and this is C2H5. So if you are going to react this with OH minus, there will not be front attack. There will be back attack. So if there will be back attack, OH will be on the left hand side. This is hydrogen, and now, oh wait a minute, this is like this. C2H5, and again this is CH3. This will be like, please write it. Let me know when you are done with this.
Yes, sir, finish.
Sneha, are you done with this? Okay, take your time. Very good. Very good, Sneha. Now we can see about SN1, which is accompanied by racemization. So I'm going to write a point about racemization too. So note to लिख लीजिए. Please write note to B. So SN1 reactions are accompanied by racemization. By racemization. That means there will be enantiomer which will be mixed in equal proportion. Like if I'm going to give you an example, we can give this is Br, this is CH3, also this is H, and also this is C2H5. So if you are going to react this reactant, so what will happen here? There will be first formation of carbocation. That means this is CH3, this will be H, and there will be CH2, CH3, that means C2H5, and Br minus will be eliminated from it. Now there are two possibilities. You can see this is C plus, that means carbocation, and it is there will be vacant orbital in carbon, and this is hydrogen. And now you can see this is CH3 and this is CH2CH3. Now OH minus, we are going to react this with OH minus, and here it is also OH minus. Now OH minus can go to this carbon, OH minus, oh wait a minute, this OH minus can attack on this. So what will be the product on the same side, front attack? So it will be like this. On the side of bromine, front attack from, and this is CH3, this is hydrogen, and this is our C2H5, that means CH2CH3. Again, if there will be back attack, OH minus will attack from here, and there will be inversion. There will be inversion. Hydrogen will come on the right hand side, OH will go on the left hand side, and this is CH3. I don't know why my OneNote is not working that much smooth. This is CH2CH3. So you can see this is plus, that means dextrorotatory, this is minus, that means levorotatory, and if they are mixed in equal proportion, there will be racemization, or these mixture are called racemic mixture. I think these are clear to everyone.
Sir, can you scroll down a little bit?
Yes.
Yes, sir.
Sneha, are you done with this? Okay, please do it. Very good. Now here are SN1 and SN2 completed reaction. Chemical reaction is elimination reaction. Write a topic. Elimination reactions. So first of all, what is this elimination reaction? So there will be concept about alpha and beta as well. So I am going to write a point. What is elimination reaction? So write with me. Then I will explain. When a haloalkane with beta hydrogen, with beta hydrogen atom is heated with alcoholic solution of alcoholic KOH potassium hydroxide, alcoholic solution of potassium hydroxide, potassium hydroxide. There is elimination of hydrogen atom from beta carbon, and a halogen atom from alpha carbon. So I will explain what is alpha carbon, what is beta carbon, what is beta hydrogen. So if they are basically removed, eliminated, so an alkene is formed. An alkene is formed because if bond is broken or removed, basically eliminated, in order to get a stabilized, carbon will make multiple bond. That means an alkene is formed as a product, as a product, and it this reaction is known as beta elimination. This reaction, reaction, that is stand for reaction, is known as beta elimination. So please write it. Then I will tell you what is alpha and what is beta. Please let me know when you are done with this.
Yes, sir, finish.
Finished, both of you. Sneha. Very good. Now see what is this alpha and beta. So always remember, like if we have an example like this is CH3, Wait a minute. Wait a minute. It's not working. Now see, to the carbon which X is associated or connected directly is called alpha carbon, and this hydrogen will be known as alpha hydrogen. And after carbon, alpha carbon, the carbon which is attached with alpha carbon will known as beta carbon, and this hydrogen will be known as beta hydrogen. And the carbon which is attached with beta carbon will be known as alpha carbon, and this hydrogen will be known, sorry, gamma carbon, and this hydrogen will be known as gamma hydrogen. So it is very simple. To the carbon which X is connected directly, that is called alpha carbon, and the carbon which is directly attached with or connected with alpha carbon, that is known as beta carbon, and the hydrogen which is connected with beta carbon is known as beta hydrogen. I think I'm clear. Is that clear to everyone?
Yes. Yes, sir.
No. This is location of alpha and beta carbon in a molecule. Alpha and beta carbon in a molecule. So this is carbon. I'm going to write it in one page. Halogen atom is directly attached alpha carbon, and the carbon adjacent to this is like, you can take an example. This is C. This is also C. Right. So this is our alpha, this is beta, this is gamma. Please write. And let me know when you're done with this.
Yes, sir. Finish.
Sneha, are you done with this? Let me know. Okay. Now see, I'm going to give the reaction or explain the reaction. Now, if we have something like this one hydrogen and there are alkyl group, and we have X. Now this. You can see if there will be reaction in the presence of alcoholic KOH, this potassium hydroxide is present in solution of alcohol X from alpha, and there will be elimination of hydrogen from beta carbon. Basically, this bond will come and form double bond here like this. And now you can see these two bonds are like this, and there will be negative, that means basically nucleophile that will associate with hydrogen. So it will be BH. BH, and this X minus since X minus. Please write it and let me know. Then I will give other examples. B is for base. That means nucleophile, you can call it electron rich species. And this X is living. Living.
Yes, sir. Finish.
Done, everyone. Now see, alcoholic KOH, it will be written, or either it can be written OH minus also. So CH3, CH2, CH2 Br, and going to react this with OH minus. Can you name the product? Nafisa, are
Yes,
you
sir.
done with this? So what is the name of the product? See what happens here. First of all, you need to see this is alpha carbon, this is beta carbon. So one of the hydrogen from here and one of the basically Br from here will come out. So there will be double bond. Main product will be like If I'm going to write it like this, okay, and then BHCH2, this bond will break and goes here and it will move. So there will be formation of double bond, that means alkane. This will be your product. Now, if there is only one alpha hydrogen, that means only one product is possible. If there is more than one alpha hydrogen, then more product will be possible. Yes or no?
Yes, sir.
Nafisa. So I'm going to give
Yes.
you again. So what will be its name? 1, 2, 3 protein. So please write it, and also write the product of this. CH3, CH2, CH2, and then CH, and here it is Br, and then CH3. Please do this first. How many products are possible, and what will be the IUPAC name of the products? Can you do this, Nafisa? Can you do this, Nafisa?
Sir, CH3, CH2
What
double
is the
bond.
name? Can you name the compound?
No, sir.
Okay. Now see, how many products are there? Only one. Nafisa, how many products are there? See the possibility. See the possibility. We can have two products here. You know why? Because this is alpha carbon, so this is beta carbon, and this is beta carbon, and both beta carbon has hydrogen that are there. So if I'm going to write it like this, CH2H, so what happens here? It will take its electron, and this bond will shift to here, and CH3, CH2, CH2, and there will be CH double bond, CH2. This bond will come here. So what will be the name of the product? Butene. 1, 2, 3, 4, 5. Sorry. Pentene. What is the name of the product?
Sir,
Pentene. It's pent 1 in or pentene. Pent
sir,
1. Now it is also
sir,
possible. This is since this is beta hydrogen. So it is also possible like this will take electron from alpha carbon and this bond will shift here. So with the product now CH3 CH. Now hydrogen is eliminated. So CH and Br is also eliminated. CH double bond. Now this will be the product. So what will be its name? 1, 2, 3, 4, 5. So it will be pent 2E. Now the question is that which one is more stable? Since we have two products, which one will be major and which one will be minor? That will be decided by a rule given by Sadjeff and also called Sadjeff rule. Okay. So basically, what does this sub Sadjeff says? First of all, you write this, then I'm going to tell you.
sir,
Yes,
sir, how do we know which one is like alpha carbon or beta carbon?
beta carbon. That's what I am explaining. B to the to which carbon? If Br is connected with this carbon, that means this is alpha carbon. Are you getting it?
Yes, sir, okay.
And the carbon which is directly attached with the alpha carbon will be known as beta carbon. So this carbon is also directly attached with alpha. That means two beta carbon is there, and the both beta carbon has hydrogen. That means beta hydrogen have there. So there will be two product possibility of two product. You can see this and
Sir, so that means like when there is alpha carbon can make like a double bond, like a bond.
alpha carbon, yes, makes bond with alpha beta carbon.
Okay,
This
yes.
is what you are
Sir, like alpha carbon makes like double bond because like
double bond with beta carbon. Am I
yes,
audible?
yes, sir, yes, sir.
Okay. Please write it and let me. Sneha, do you have any doubt? Sneha, what is the problem here? You didn't get it. Should I explain it again? Nafisa and Hamza, I'm going to take another example. Please write it first.
Yes, sir.
Everyone done with this, so that I'm going to start
Yes, sir,
explaining.
finish.
Okay. Now see, I'm going to take this example again. If we have CH3, CH2, and CH2Br, now you can see that. Please respond this. This is alpha carbon, then this is beta carbon. Yes or no?
Yes, sir.
Now this beta carbon has beta hydrogen. So what you need to do is very simple. What you need to do is very simple. This is beta hydrogen. So this will take electron from this carbon and this bond will come here. So what happens here is very easy. You can see you need to just draw the double bond between beta carbon and alpha carbon. So what we will get, CH3 CH double bond CH. Now I am going to again explain it from very basic. If you have CH3 CH and here it is H and here it is CH2 Br. Now you can understand or find this is alpha carbon. So if it is alpha carbon, what happens here? It will take electron from bromine. It will take electron from bromine and this is CH3 CH positive charge. Yes or no?
Yes, sir.
Now what happens here? Going to react this OH minus. So this carbon will take electron from hydrogen and hydrogen will be H plus now. Hydrogen will be H plus and combine with this OH to form H2O. Now if this carbon will take CH3 and CH negative and then CH2 plus, yes or no?
Yes, sir.
Tell me. Now, one negative charge that means two electrons. One negative charge that means two electrons, and one electron will be donated to this carbon, and there will be formation of double bond, and there will be formation of double bond. So this will be your product. So this is the first example that I wrote. Please write it and to bromo penta. Everyone done with this?
Yes, sir.
Yes, sir. Finish.
Very good. Now I'm going to take another example that we have already explained. Now you can see what we had, CH3, CH2, and then CH2, then CH, Br, and then CH2 and H. Now you can see that this is alpha carbon, so this is beta carbon and this is beta carbon also. Yes or no? And we have beta hydrogen. Yes or no? Please tell me. Nafisa, Hamza.
Yes, sir.
Now you can see. First, I'm going to write OH minus in the presence of alcoholic KOH. What happens? This bond will shift to here and this bond will break. So what will be the first product? CH3, CH2, CH2, and then CH and double bond CH2. Yes or no? Now there is another possibility. You can see there is beta presence of OH minus. What happens here? This will come to this and this will eliminate CH2 and then double bond CH and then CH3. Got it, Nafisa? Uh, Let me know when you are done with this. Hamza and Sneha, please do reply.
Done, sir.
Very good. Nafisa, are you done with this? Very good. Now see which one is more stable, which one is major product, and which one is minor. That will be decided by Sadjeff rule. That will be decided by Sadjeff rule. And what does this Sadjeff rule says? I'm going to write it. It is very easy. Please write it and let me know in pent 1 in and pent 2 in, which one is more stable or major product. Are you done with this, Nafisa?
Yes, sir. Finish.
So basically, the alkene which have more part or alkyl group attached with that will be more stable or major product. So can anyone tell me which is major product? Which is major product, A or B? You can see this is alkene part, double bond, and to this double bond there is two alkyl group, this and this. And if you are going to look at it, it has only one alkyl group. So this will be minor product and this will be major product. Is that clear, everyone?
Yes, sir.
Very good. Please write it major and minor and let me know. Let me know when you're done with this. Are you done with this?
Yes, sir. Finish.
Very good. Now, question is predict all alkenes. That would be formed by dehydro halogenation of the following halides. The following halides. With sodium ethoxide in ethanol. And identify the major alkene. So the first question I'm going to give you is 1 bromo, 1 methyl cyclohexane. It's very easy. In the previous question we have write potassium hydroxide in alcohol and it is sodium ethoxide in alcohol. Can you do this? First write the structure of this reactant and then it's very easy. Are you done with this, Nafisa? Or if you have
Yes,
any
sir.
doubt, please ask me.
Yes, sir.
Do you have doubt or are you done with this?
I'm done with the structure.
Okay. So up to this question, right? Can you
Yes.
tell me the name of the product? Hamza and Sneha, what about you?
No, sir.
Okay, no problem. Okay, let me know. Have you write the structure of this compound? Have you written it? Like
Like,
cyclohexane, first write
yes, sir.
cyclohexane.
Cyclohexane, and then
This
after
is
that,
cyclohexane. And one bromo
br
and
will
one
be,
methyl, that means
yes, sir.
bromine and methyl. Yes or no?
Yes, sir.
Now you
Yes,
can
sir.
see this is alpha carbon, so this is beta carbon, and this is also beta carbon. Yes or no?
Yes, sir. Yes, sir.
So beta hydrogen will be also here, and beta hydrogen will be also here. So what you need to do is here it is written that sodium ethoxide in the presence of ethanol H2O2H5 ONA, eth, that means two carbon ethoxide, and ethanol, that means C2H5OH. Everyone, are you getting it till this?
Yes, sir.
Now see what happens. This Br will move. So this hydrogen will come to this bond for this. So what we will have is double bond here and
One methyl
CH3
chlorohexane.
and cyclohexene. And now see, if this will move, this bond will come and
Cyclohexane, yes, sir.
hexene. Now there will be double bond CH3. And you can see both are same. Both are same, yes or no? So only one product is
Yes,
possible.
sir.
One methyl
Chlorohexane.
cyclohex, one ene or
Cyclohexane, yes, sir.
cyclohexene. Hamza, what about you? Got it? Or you need another explanation?
No, sir.
Okay, please write it. Only one product will be possible. Let me know when you're done with this. Everyone done with this?
Yes, sir.
Okay. Now another part. This is the first part of the question. Now the next question is basically we are going to eliminate this 2 chloro, 2 methyl butane, 2 chloro,
Sir, two products can be formed.
can you name the product?
2-methyl butyl and 2-methyl butene.
Very good. What about you, Hamza and Sneha? Which one is more stable? The most important question.
2-methyl
Nafis,
2-methyl 2-butane, butene.
butane. Very good. Because there will be more alkyl group along double bond. Okay, I'm going to give you the third and Hamza, let me know the answer of this, please. And this is basically 2 comma 2 comma 3. Trimethyl 3 bromo. And are you done with this, Hamza? Nafisa, are you done with this? Sneha?
Sir, I don't know how to do the third one.
Last one, right? So
Yes,
first
sir.
of all, first of all, I'm going to explain the third one. So first of all, we are going to write the structure. So the structure will be CS3 2 comma 2 comma 3 methyl and 3 bromo, and then pent, and that means 4 carbon and it's fifth. And we need to react this with C2H5ONO, sodium ethoxide, in the presence of ethanol, that is C2H5OH. Now see what is this. This is alpha carbon, so this is beta carbon, and this is beta carbon, but this does not have beta hydrogen. Does not have beta hydrogen. Are you getting my point, Nafisa?
Yes, sir.
So it is not possible to react from this side. So only one product is possible there. Or wait a minute. This is also beta carbon. Yes or no? So 3 beta carbon is possible.
Yes, sir.
This, and this. But here it is not possible. The reaction is not possible because it doesn't have beta hydrogen. So 2 product is possible. So what I'm going to do is H. So first of all, I am going to do this and bond this. So what we will get CH3 and then C, and then CH3 will be here and CH3 will also be here, and again C, and here it is CH3, and again this is double bond, and then CH, and then CH2. Got it, Nafisa?
Yes, sir. Yes, sir.
Nafisa, this is
Yes, sir.
CH2H. So what happens here? This will go like this and this will be eliminated. So what will be the product? CH3 and then C. CH3 is here and CH3 is also here. And again, C double bond CH2 will be here, and then single bond CH2 and then CH3. Can you tell me which one is more stable and which one is less stable?
The first one is more stable.
Because a long double bond, we have one, two, three alkyl group, and a long double bond, we have only one and two. So this will be major
Yes, sir.
and this will be minor. Please
Yes, sir.
write it.
Sir, can you scroll down a little bit?
Yes, why not?
Yes, sir, finished.
Very good. Hamza, what about you, Sneha? Are you done with this, Sneha? So, do you need explanation for this 2-chloro-2-methyl-butane?
Yes, sir.
Chloro-2-methyl-butane. So you can see the structure will be CH3, then CH3, and then Cl, and then CH2, and then CH2. Now, first of all, this is alpha, then this is beta, then this is beta, then this is beta. So I'm going to write it. Please concentrate here. This is CH and H. What happens here when this will go like this bond will move to this, and we will have a product in sodium ethoxide and ethanol. In presence of that, this will be C, and then CH3 will be here, and then double bond, and then CH, and then CH. Now, with another color, I am going to represent this. You can see this is CH2 and this is hydrogen. So what happens here, chlorine will go eliminated and hydrogen's bond will be like this, and we will have CH3 and then C, double bond CH2, and then CH2, and then CH2. Now from another color, you can see this is CH2, and this again will move, and this will move to this carbon. So what we will have, this will be CH2, double bond C, and then CH3, and then again CH2, CH2. Now if you are, you can see this and this product are same. So only two product is possible, this and these both are identical. If you are going to name it, you will get it. If you are going to name it 1, 2, 3, 4, so the name will be 2-methyl butene. And if you are going to name it 1, 2, name will also be 2-methyl butane. And if you are going to name it 1, 2, 3, 4, so it will be 2-methyl butene, and it will be major product because along double bond you can see we have 3 alkyl group, and with this we have only 2 alkyl group.
Yes, sir.
Okay, so this is it for today, Nafisa and everyone.
Thank you, sir.
Thank you.
Thank you.
Thank you, everyone.